good morning, or good afternoon, right now. Sorry if I speak in English, okay? But at the last moment, I knew that I could speak also in Italian. It was better. But unfortunately, I prepared all the slides in English, so I say, okay, I speak in English. Okay, sorry for that. I want to thank the PARSEC, obviously, to invite me to speak about this interesting technique, and then the organization, and I found again Giovanni Trioli and Francesco Invernizzi and Giuliano Boni, who I know since a long time. I appreciate and congratulate for this organization. Okay, so we start. Here this morning speaking about maceration, and all the time I'm really shocked about, because I think a lot of people speak about maceration but they don't know really what maceration is and how the berry is working, because this berry is already macerated inside when it's going to ripe. I don't know if you know that the berry, okay, inside, at the ripening stage, the oxygen inside the berry is 0. It's like to have a carbonic maceration inside the berry, which means that in the berry, already you have a maceration before harvest. And this is the reason for which birds, wild pork, fox, take the right maturity stage to eat berries. This happens even for cherries, okay? When you are ready to pick the cherry from the tree, for sure you have a bird before you take the berry, because they know when is the time to harvest for eating. And most of us, we don't know really which is the maturity stage to harvest the grape. And this is the reason for which we have only 50–60% of destruction. Okay? Whatever is the system we used, we always has maximum 70% of extraction. And then we have to use some other techniques to extract from residues the liquid that remains. So the maceration is not an easy task. No? That's why the research carried out from PARSEC interested to me from a physics viewpoint. And then okay. Yeah, okay, go ahead. Okay, the principle of maceration is to transfer from solid to liquid what is interested for the wine, okay? And so we have a physical process, okay, which is a cell breakdown, okay? And then we have infusion and leaching. But if you see the factors, okay, let me see. All right. If you see the factors, what happened? The factors affecting the maceration are a lot. Okay? So when you are working on field, on the vineyards, okay, you have to be in mind what's the process of maceration. Because already working in the vineyard, okay, you can have a better berry to have better extraction. Not probably more extraction, but better extraction. Okay, this is an old paper, 2008, by the group of, here, I think it was from Zaragoza. And they explain very well what happened during the maceration. The transfer between skin, the line, I don't know why it's moving, okay. Okay, it's moving fast. Anyway, okay, the line is going down is the content of anthocyanins, okay, in the skin, and the line going up is the content of anthocyanins in wine. So there is a complete transfer from skin to wine during the maceration process. Obviously, this is depending on the ripening stage. This is the case of the same paper in which the white circle indicates that you have a great extraction when the berries are riper, but you know this, obviously, okay? And then another thing, when we speak about maceration, cell wall enzymes are activated from hormone, which is ethylene, which is very important during the ripening in the process. Nobody is taking care about this aspect, but the berry cell wall enzymes are very affected, are pushed from ethylene. So ethylene is the ripening hormone. Okay, so which means increase, even for grapes is non-climateric fruit, okay, but ethylene has an important role in the activation enzyme. But we have to consider not only cell wall, we have to consider also cell membrane, because several volatiles are released by cell membrane destruction, oxidation. I think the C6 compounds like hexanal, trunks, and cheese, and so on. Now we go forward. This is a nice paper. Okay, I've been working since 2000 on technology for grape dehydration. Okay, so to make Amarone wine. Okay, so I'm very expert on physiology and technology for these techniques. And this is paper from group of Verona, Zenoni et al., a beautiful paper, a kind of basic paper for studying what happens when you have water loss for grape, okay? And then you see the different, yes, sorry.
You can keep press the central button when you, but it's moving.
Yeah, it's just moving. I don't know. Anyway, okay. Okay, you can see this electronic microscope image and then the bunch of the different varieties. You can see from the darkness of the area below the skin, okay, the thickness of the tissue. So depending on the thickness, obviously you can have higher or lower extraction. And you need more power or less power to extraction, okay? So there are several factors affecting extraction. Grape juice, we speak about grape juice, we speak about the free juice, gravity juice, leaching juice, interstitial juice. We need to remove this juice, obviously, okay? After pressing, after crushing, we have solid and liquid. And so there are two parts, and we have to remove some solid from solid, what it is of our interest. The two main physical actions are infusion and leaching, okay? Infusion is just like when we make tea, okay, we make infusion. But infusion is not enough, because infusion involves dissolution and dispersion, okay? But then you need the leaching. A leaching, what is doing leaching? When we make a pumping over, we make leaching, for instance, okay? What is doing the leaching create a continuous different pressure and different concentration between solid and liquid, okay? So, the technique which have been developed by PARSEC, okay, involve a specific physical feature, okay? Disintegrating waves. And this is the feature. Natural frequency of resonance, okay? A resonance, everybody, even me, I'm speaking, I have a resonance frequency, okay? So resonance frequency is a natural vibration of each solid liquid when the solid liquid is affected by a force, okay? And resonance occurs when external force amplifies the motion of the system. For instance, when we have a swinging and we push, okay, at a certain moment, you don't need to push. It's going by itself, okay? Or, and the other, if there is experience about making sounds, ultrasounds, and then the glass start to vibrate, and at a certain moment they break. Okay, so this is because the resonance is affected, and these are different frequency of resonance. The red one, there are only one wave up and one wave down because the frequency is very low. But the frequency increase in the frequency, if I shout, okay, the frequency increase and the waves go down very fast, okay, and they're small. Okay. Okay, when the disintegration occurs, when the force which I apply match the resonance of the body, okay? So this is the case. These are different curves, okay? At the low level, okay, the body is vibrating, okay? But the body breaks when the resonance amplitude increase. Okay, so you have the peak at the point the body break. And this is a funny story. In the, okay, in the 1940, okay, this is an experience of homemade. When you bubble with the straw in a glass with solid material, you arrive at a certain point that the bubbling goes out from the glass is because you have reached the resonance effect, okay? And this is the story. In 1940, when here there was a Nazi-fascist war, in the United States, they built the bridge. And they didn't know about the resonance, okay? So there was just a regular storm, 50 miles per hour wind, but was enough to make the resonance effect, okay? And you can see how strong was the resonance. And at a certain point, the wind reached the resonance of the bridge. It collapsed down, okay? They didn't know about the resonance, okay? And this is what we are doing, okay, with the, and this is another experience about the resonance. Look at this. A friend of mine from University of Leuven, Bart Nicolai, okay, he simulated what happens when acoustic waves touch the fruit, okay? And this is the movement the fruit is doing. Okay, they are dancing, okay, but really they are shocking. So when you send an acoustic waves, the pear, the apple, they start to move. You don't see, obviously, but they move. They go in natural resonance. they go in natural resonance, which is the energy these apples gates. If you see this image, still from Bart Nicolai, okay, the red part, okay, is where the energy is higher, okay? So moving for natural resonance, okay, you have some part in which the fruit gets more energy than in the other parts. And this is the part in which you have disintegration of the fruits, okay? That's why before the paper before, the presentation before about the ultrasounds, okay, it was working in this direction, okay? Because increasing the frequency, okay, low frequency, okay, and low power, high frequency, okay. Now, what's the difference between pushing air bubble from the bottom of the tank, where you have must, okay, and using the air mixing system, okay? If I push air from the bottom of the tank, okay, with a big bubble, okay, which is not chewing gum, but is a huge bubble, okay, what the bubble is doing, they're moving like the mud of volcano. The mud of volcano is blowing like this, plup, plup, plup. Where there is less resistance on the top, okay, the bubble come up, okay? So it's not a perfect movement of the surface. It's not a perfect breaking of the cap, okay? Because where there is less resistance, the air goes out, okay? That's why most of the time they use some kind of perforated tools to break the bubble and making smaller bubble and more diffuse bubble, okay? Now, the disintegrate wave, okay, is working different way because through specific nozzles placed in the tank at the low level, okay, so in the bottom of the tank, and using a specific applied force to have a specific frequency and to have a sequential movement of the air coming out from the nozzles, okay, you can create waves. You create waves. Like it happens with the tide on the sea, okay, there is an effect which is called tidal resonance, okay, because they are the waves made by the sea along the coast, okay? And this is what is made by the air mixing. So you can understand how difficult it is to manage the right frequency and the right application force, okay? So the system, you can see here, what happens here, you see the movement of the mast. Right now, the frequency is low, okay? Now the frequency is increasing because the waves are moving from it, and then the frequency keep the top. Is breaking the cap, okay? Now, what we want that the cap is not formed. We don't want disintegration of the cap. We want that the cap is not formed. So we want to maintain the most in continuous agitation to avoid the formation of cap. Why this? Because if I make a disintegration is so strong, okay? And you have small residues, then they catch the color, okay? So when you use the air mixing, we are following several winery around the world, okay? And 2 years, last year, we have one of the most important winery in Italy, Falesco Winery, belonging to Riccardo Cottarella, okay, one of the most important enologists in the world, okay? And we made the extraction. It was fantastic, but we didn't reach the disintegration, okay? We just move the must, okay? So, coming back at the first slides, okay? The physical process, the cell breakdown, we don't want cell breakdown. We just want leaching effect. We want to just to revolution continuously this small part of the solid part of the must, skin, pulp, okay? So we want to move and make continuous pressure difference, concentration difference to permit the extraction from the solid to liquid. So it's continuous. And obviously, you need for this to give more importance to the maturity stage, ripening, and also to the growing environment, how you treat, you deal with the grapes in the vineyard. Okay? What does it entail in qualitative terms? Okay? The continuous movement of the liquid facilitates leaching. Okay? The phase juice decreases, and therefore there is more no chemical compounds in the liquids. Okay? But another important point is this one. When you have, especially in huge tank, very high tank, you have pockets or sacs of temperature difference, which make a movement to the liquid, obviously, but you have sac temperature. It's very hard to keep uniform temperature in 10-meter high, 15-meter high tank, okay? So, with air mixing, keeping a continuously movement, okay, I can keep the uniform temperature which is used. There is a very interesting paper from University of Davis about this, which is the layer of temperature in the tank in a thermocontrolled temperature, okay? Is the group of Anita Oberöster, okay? Which different temperature in the tank. And these are small tank. You can imagine when you have a big tank, huge tank, okay, which are the difference in terms of temperature. So with air mixing, you moving continuously, okay, continuously the mass, you don't have any layer of temperature, but you have uniform temperature. Now you can, probably you ask, what's the energy consumed? Nothing. Because when you go in resonance, it's like swinging, okay? They go, the waves goes. At the beginning, you need the energy to make waves, and later on, the waves go by itself, okay? So it works better, extraction is better, and so, okay? Another point, the non-invasiveness of the process prevents the extraction of unwanted compounds such as proanthocyanins from the grape seed, if they are not perfectly senescent, as you know, okay. And then another point, I'm working a lot on this kind of type of wine with high sugar content, and there is a problem of glyceropyruvic fermentation, which sometimes lasts too much, okay? Increasing volatile acidity, okay? Now, with air mixing, the glyceropyruvic fermentation goes straight and change to alcoholic fermentation. Okay? So the possibility to create volatile acidity, which is one of the most critical points for sweet wine, but also for Amarone wine, okay, with their mixing is avoided. Now, this in the top left side, okay, looking so on this part, okay, you can see that the temperature, how after starting the air mixing, which are represented by the segment, the arrow vertically on the x-axis, okay, you can see the green temperature line, it goes down immediately after air mixing starts. Because the temperature in different position, the difference disappears. And the temperature is still the same on the top and the bottom, okay? And then you can see the alcoholic fermentation, how faster goes down on the right side, alcoholic fermentation trend, and this is the total polyphenol trend, the experiment of this last season, made in the Falesco winery, and you can see how great is the extraction, as faster extraction in the beginning, and then the fermentation, and much before than the control, the regular using system like pumping over or just the pillars going down in the master and so on. Okay, precaution and troubleshooting, which is, I mean, some criticism for us, okay? So everything is perfect, it seems. Always we speak at the symposium, the congress, it seems everything is perfect. Not always is perfect, obviously. We have to use the brain to use these techniques, okay? That's why my presentation was before than my colleague, which is an enologist working in the bodega, okay, testing directly, and mine was a kind of basic relation on the techniques. Because there are some points we have to face, obviously. We have to use the brain, excessive cup movement, improper management, or excessive cycle frequency can disintegrate, can reach the famous natural resonance frequency and disintegrate it to give more leads, okay? And we don't want this, okay? So the air mixing is great if you are using with rationality, okay? I think it was the last one. I hope to be on time, okay? Thank you.